Hi everyone, welcome back to my YouTube channel. So my name is Rica Casabuena with my groupmate Jose Alvaro from ECE41 of the Electronics Engineering Department of the De La Salle University Das Marinas. And for today's summative assessment, we will be having our summative assessment number 1 for our final period, okay, which will be involving the use of our Raspberry Pi and our LEDs. So for our instruction, we have to program the Raspberry Pi to carry out the task being asked as shown below. So we have to submit the code using Python or Node-RED programming. So in our case, we'll be using Python as our programming language. So our condition is that once PB1 is pressed, or let's say our push button 1 is pressed, sequence 1 will commence, or sequence 1 will be performed and will be running for 10 seconds. So that will be our duration, which is 10 seconds. Then after that, it will proceed to our sequence 2, okay, for 5 seconds and loops back again to sequence 1. So probably this will be a repeating process, okay? This will just repeat the process as long as we're not stopping running our Python command. So probably this will be a loop, okay? Our program will be a loop. So this will be our sequence 1. So we'll be using, okay, 2, 4, 6. We'll be using 8 LEDs, okay? That will be connected to our push button 1. So we'll be needing only one push button. We'll be needing as well 8 LEDs. Colors will be up to you. And we'll be needing as well 8 resistors. So it will be better if we'll not be exceeding 500 ohm resistor to make sure that the LED will light up. So the process will be, the sequence 1 will be lighting up from left to right. Then after the sequence 1, which will run for 10 seconds, probably that will be slower than the sequence 2. Sequence 2 will happen and the LEDs will light up respectively from right to left in a duration of 5 seconds. After that, sequence 1 will happen again, and after that, sequence 2 will happen again, and the whole process will be repeating, okay, will be happening repeatedly. So basically, that will be a loop. So we'll be proceeding with our Python code. So understand it for you to fully know how will the LEDs operate.
So here is the Raspberry Pi code for this assessment, wherein we will be utilizing two sequences in a loop. So the first line, import rpi.gpio as GPIO, is the general purpose input-output. Then from line 2, which is from time import sleep, is the setup for the time delay. So next one is GPIO set mode. GPIO BCM is the setup for BCM GPIO numbering. Then we set the GPIO set warnings as false. So as we can see here that the line 6 is the code for the push button, which is the pin 2 set as input. Then line 7 to 14 is the pin configurations such as 2, 5, 6, 13, 19, 12, 16, 20, 21 as declared as an output. Then count equals to 0. Then we have the GPIO output pins, which is 5, 6, 13, 19, 12, 16, 20, 21 set to off or 0. Then we have the while condition here. If we press the push button, which is in pin 2 of the Raspberry Pi, is false, then we have the sleep, which is the time delay of 0.5. Then if count equals to 1, then we will be proceeding to the sequence 1, which is 10 seconds from right to left. So we have the outputs of 5, 6, 13, 19, 12, 16, 20, and 21. Then we have the time delay for each LED of 1.25 seconds. Then as we can see here that we have the combination of the pins and the ones and zero. So ones and zero means that it will be either on or off. So we have that combination for each of the LED. Then we will be proceeding to the sequence 2, which will be the sequence 5-second sequence from left to right. So as we can see here that we have the output pins of 21, 20, 16, 12, 19, 13, 6, and 5. So we utilize the delay, which is 0.625 for each of the LED. Then the combination, whether it fits on or off, which is the ones and zero for each of the LED. Then lastly, we have the sleep of 1 second. Then this is the code for the sequence that we will be using in this summative assessment. So let's proceed to the circuit. So here is the application of the program in the circuit. So we use the push button for this part of this experiment and the Raspberry Pi. So we declare the pin 2 of the Raspberry Pi as the push button, while the pins 5, 6, 13, 19, 12, 16, 20, 21 is declared as an output for the 8 LEDs. Then the LEDs are connected to the ground. Then we have the common ground as well for the Raspberry Pi connected. Then once we press the push button, we will be having the first sequence, which is the sequence from right to left with a delay for each LED of 1.25 seconds. Then after that, we will be having our second sequence, which is the sequence from left to right with a delay of 0.625 seconds. Then we will be having these two sequences as a loop. So the loop does not end until we stop the program from working. So that's it for the summative assessment in this part of this experiment.
So for our conclusion, okay, with our assessment, with our summative assessment today, so as a general thought from our experiment, the Raspberry Pi is a low-cost credit card-sized computer that plugs into computer, monitor or TV, and enables a lot of programming functions in accordance to the design needs. It is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Scratch and Python, which we used a while ago. So in this examination, we conclude that Raspberry Pi is good to use in terms of programming electronic components such as LEDs, which can be also applied in the operation principle of Christmas lights, which is also seen in the application or in the demonstration that we showed a while ago with our 8 LEDs. So again, my name is Rica Casabuena in behalf of my groupmate, Jose Alvaro II from ECE 41, and that's our summative assessment 1 for the final period. I hope you learned a lot and you enjoyed watching the vlog about our electronic assessments, and I hope I will be seeing you on our next electronic vlogs. So bye for now.